You're welcome to my channel. Let's discuss matrices or metrics as the case may be. Matrix is singular, matrices is plural. So we are going to start with introduction to matrix. What is a matrix? A matrix can be defined as what? A set of numbers arranged in rows and columns to form what? A rectangular array. What does that mean? What this means is this. For example, if you have something like this, 1, 2, 3, 4, 5, 6. This is a matrix. Why? Because it comprises of what? Sets of numbers arranged in rows and columns to form a rectangular array. First, we now need to know what a row is and a column is. I will advise you bring your pen and paper and remove any distraction that is going to prevent you from learning what I'm about to teach you now. Because what? By the time you are through with this particular video, you will be well grounded in what a matrix is. All right, so let's go ahead and get these insights. Now when you look at this is a matrix. The question now is, what is the row of a matrix? What is a column of a matrix? When you look at this particular question now, or this particular example, the rows of a matrix are the horizontal group of numbers. Now notice that when you group this in horizontally, this is the first group, this is the second group horizontally. So all these horizontal arrangements are called rows of the matrix. So it means that for this matrix we have two rows, right? This is the first row and this is the second row. Now for columns are the vertical arrangements. The vertical arrangement. So you notice that we have 1, 2, and 3. That means we have 3 columns, right? So we have 3 columns. So now I believe we know what rows of a matrix are and columns of a matrix are. Now let us give another example. For example, if we have a matrix like this, 1, 2, 3, 4. How many rows does this matrix have? 2, right? Yes, because we have number 1, number 2. Horizontally, we have 2 groups. So we have 2 rows. Now, how many columns do we have? We have number 1 and we have number 2. We also have 2 columns. Okay, so that means that this matrix has 2 rows and 2 columns. I would like you to pay attention and follow me so that you will be able to know why we are learning these rows and columns. I'm going to give one more example and we are going to switch into the use of these rows and columns in naming the order of a matrix. So in order to be sure that you understood what I explained, let us find how many rows and columns does this have? How many rows and columns does this have? Now this matrix, if you look at it, you will notice that we have how many rows? 3, right? Yes, because you have this 1, you have this second row 2, and you have this row 3. 1, 2, 3. So we have 3 rows. Now, how many columns do we have? Vertical arrangement, we have just 2. 2 vertical arrangements. That means we have 2 columns. We have 2 columns. So with this, I believe that you can now explain or tell the number of rows and the number of columns of any matrix you come across. Okay, nice one. Let's go ahead towards order of a matrix. Now, what is the order of a matrix? The order of a matrix is what? For you to name a matrix, name the order of what? A matrix. You name your rows first before your columns. You see why I was trying to explain the meaning of rows and the meaning of columns of a matrix. Now, to name the order of a matrix, for example, if we are given that A is equal to 2, 5, 3, 6, 2, 1, and we are asked what is the order of this matrix? First of all, we need to know how many rows does this matrix have. It has what? 1, 2, 3. 3 rows, because horizontally we have 3 groups. So you name that 3 first. The rows is named first. So we have 3 rows for this particular matrix. Now, how many columns does this matrix have? It has 1, 2. Only 2 vertical arrangements. So these 2 will be here. It means that the order of this matrix is what? A 3 by 2 matrix. A 3 by 2 matrix. Anybody that sees this will know that this matrix has 3 rows and what? 2 columns. 3 rows and what? 2 columns. Do you understand? We have 3 rows, 1, 2, 3, and we have 2 columns, 1, 2 columns. Okay, let us go ahead and give another example under this order of a matrix. For example, if you are given a matrix that is in this form, we have 1, 2, 3, 4. And we are asked to do what? Name the order of this matrix. How do we do that? The order of this matrix is, first of all, how many rows does this matrix have? It has number 1 row, number 2 rows. Notice that we have 2 what? 2 horizontal arrangements. So we have 2 rows. We write it first by, then how many columns do we have? We have 1, we have 2. Our vertical arrangements are 2 also. So that means we have 2 columns. So it means that this particular matrix is what? A 2 by 2 matrix. A 2 by 2 matrix, whereby the first 2 represents the number of rows of this particular matrix, and the second 2 represents the number of columns of this matrix. So I believe with these 2 examples, you can be able to name any matrix you come across according to its order. Okay? All right. Let us go ahead and discuss types of matrices or types of matrix of a matrix. We have 4 types of a matrix. Number 1, let's discuss a square matrix. A square matrix. Now, if you have followed me to this stage, it really means that you are enjoying what I'm doing. So I will encourage you to hit that subscription button. Please subscribe to the channel and on your notification bell, because I wouldn't like to miss you when I post the next video. Okay, if I come online for the next video, I wouldn't like to miss you. So please subscribe and also do what? Hit your notification bell. Now, what is a square matrix? A square matrix is a matrix that has what? Equal number of rows and columns. When the number of rows equals the number of columns, then you have a square matrix. Okay? For example, if we have something like this, 2, 3, 4, 5. This is a square matrix. Why? Because how many rows do we have? We have 1 and 2. So we have 2 rows by how many columns do we have? We have 1 and 2 as well. 2 columns. So we have a 2 by 2 matrix, meaning that the number of rows is equal to the number of columns. So it is a square matrix. Another example is a 3 by 3 matrix, a 4 by 4 matrix. Let me give an example of a 3 by 3 matrix. You have 2, 3, 4, 5, 6, 7, 8, 9, let's say 3. Okay? Now, how many rows do we have here? We have 1, 2, 3. We have what? 3 rows by how many columns do we have? We have 1, 2, 3. 3 columns as well. So what do we call this? A 3 by 3 matrix, and is what? A square matrix, because the number of rows equals the number of columns. You see why I asked you to get your pen and paper, because you need to jot down so many things that you need to go back to and use it to refresh your memory when time comes. Okay? And if you are preparing for an exam, this is a way for you to refresh your memory and to study this particular topic in a very fast and easy way. Okay? All right. Now, I believe with this, you know what a square matrix is all about. Now, let's go over to what? A single matrix. A single matrix. Now, what is a single matrix? A single matrix is that matrix that what? Its determinant is equal to 0. Now, do not worry. We will get to determinant of a matrix, and we are going to do it in a separate way that you will understand it. We are going to teach it separately. For now, I want you to follow me. When you say that the determinant of a matrix is 0, that means that matrix is a single matrix. I'll just give you a hint on how to determine the determinant of a matrix. For example, this particular matrix now, if we have 2, 4, 3, 6, this particular matrix is a single matrix. Why? Because if this is A, the determinant of A, this is how to get it. Determinant of A is going to be equal to, this right, what is it called, diagonal will multiply itself. The left diagonal will also multiply. So 2 times 6 will give you 12, minus 4 times 3 will also give you 12. Okay, see, let me write it out so that you will not forget. 2 times 6, okay, minus 4 times 3. So the one that is the right hand diagonal, or the diagonal in the right hand side, is going to subtract what? The one on the left diagonal. So you have 2 times 6 minus what? 4 times 3. Okay, so you are going to have 12 minus 12, which will give you 0. Now you see, this particular matrix is a single matrix because its determinant is what? Equal to 0. So to get determinant of a matrix is very easy. Just do your right diagonal, subtract your what? Your left diagonal. That is it. Now we are through with what a single matrix is all about. What of a null matrix? We have null matrix. Now, what is a null matrix? A null matrix is a matrix that all the elements in the matrix is 0. They are all zeros. For example, if you have that A is equal to 0, 0, 0, 0, this is a null matrix. Okay, let us go ahead and, okay, you can also call this null matrix zero matrix. You can call it zero matrix. Now, which other type of matrix do we have? We have unity or identity matrix. Unity or identity matrix. Unity or identity matrix. Now, what is this? This type of matrix is a matrix that what? Its right diagonal is only 1. You have 1 as what? Its right diagonal. Every other element in the matrix is 0. See what I mean here? If A is equal to, you have 1, 0, 0, 1. This is what? A unity or identity matrix because the right diagonal, all the elements in the right diagonal are 1. Other ones are what? Zeros. It must not be this. If we have something like this, it is also a unity matrix. For example, if we have 1, 0, 0, 0, 1, 0, 0, 0, 1. Can you notice something? You notice that all the elements in the right diagonals are what? 1. The elements are 1, 1, 1 in the right diagonal. Every other elements are what? 0. I told you to get your pen and paper because from here we are going into addition and subtraction of matrices. So don't relent and remove any distraction like I said initially. Okay, let us go into addition and subtraction of what? Matrices. Addition and what? And subtraction. Addition and subtraction of a matrix. Number 1, this is what you have to put in mind. If you want to add or subtract 2 matrices, they must be of the same order. We have learned about order of a matrix, right? Yes. What does that mean? It means you can only add a 2 by 2 to a 2 by 2, or subtract a 2 by 2 from a 2 by 2. A 3 by 3, we only add a 3 by 3. A 2 by 3, we only add a 2 by 2. Okay? So let's go ahead and give examples. Example. Now, example, we are asked to add together. We have 2130, 2130 plus 2314, 2314. Now, this is what you have. To add two matrices together, very easy. Let's go ahead and do this. Now, when you have something like this, look at corresponding elements. What do I mean by that? Remember, if you look at these two elements now, 2 is corresponding to 2. What does that mean? It means that 2 and 2 are occupying the same position in their respective matrix. So 2 is the first number, 2 is also the first number here. 1 is the second number, 3 is the second number. So 1 and 3 are corresponding elements. Okay. Now 3 and 1 are corresponding. 0 and 4 are corresponding. Okay. So it means that to add these two matrices together, we add the corresponding elements, the ones that are occupying the same position in their respective matrices. Okay. Now let's go ahead and do this. So this will be equal to 2 plus 2, 2 plus 2, 1 plus 3, 1 plus 3, 3 plus 1, 3 plus 1, 0 plus 4, 0 plus 4. So I believe you understood this. Okay, let's go ahead and get the final result. This is equal to 2 plus 2 will give us what? 4. 1 plus 3 will give us what? 4. 3 plus 1 will give us 4. And 0 plus 4 will give us 4. Wow, this one gave us 4, 4, 4. 4, 4, 4 all through. Okay, if you did not understand this, let me give you another example and explain it. Now let's solve another one. The second example, we are asked to add 2, 2, 3, 2, 2, 3, 1, 0, 4, 1, 0, 4. We are asked to add it to what? 6, 0, 4, 6, 0, 4, 2, 3, 1, 2, 3, 1. Okay, this will give us what? As usual, we are going to add the corresponding elements what? Together. Now, what are the corresponding elements? The corresponding elements are 2 and 6. They are occupying the same position in their respective what? Their respective matrices. So it means that if I should carry this one and put it on top of this, notice that 2 and 6 will be on top of each other. 2 and 0 will be the same. 3 and 4 the same. Okay, so that means to add them together, we're going to do 2 plus 6, 2 plus 6, 2 plus 0, 2 plus 0. Let me use another place. So this is equal to, so you're going to have 2 plus 6, 2 plus 6, 2 plus 0, 2 plus 0, 3 plus 4, 3 plus 4. They are occupying what? The same position in their respective matrices. Now we have 1 plus 2, 1 plus 2, 0 plus 3, 0 plus 3, 4 plus 1, 4 plus 1. Now this is equal to 2 plus 6 will give us what? 8. 2 plus 0 will give us what? 2. 3 plus 4 will give us what? 7. 1 plus 2 will give us what? 3. 0 plus 3 will give us what? 3. And 4 plus 1 will give us what? 5. So you notice that our answer is 827335. Now, I want you to pay attention to this. Note, just notice this. Notice that we added a 2 by 3 matrix together, right? We added a 2 by 3 matrix together. And the answer we got is also a 2 by what? 3 matrix. So whatever you add together, the order is going to be the same with the order of your results. Okay? All right. I believe you understood this well. Now, this we have been doing addition, addition, addition. Let us do subtraction. Let's do subtraction, okay? So, for example, we are asked to do this. They said 3, 8, 9, 4, okay? Minus 2, 6, 7, 3. We are subtracting right now, okay? Now, how do we do that? Just like the same way we solved our addition, we are going to do the same to subtraction. We are going to subtract the corresponding elements from each other. We are subtracting the corresponding elements from each other. Now, this is going to be what? 3 minus 2, 3 minus 2, 8 minus 6, 8 minus 6, 9 minus 7, 9 minus 7, 4 minus 3, 4 minus 3. So what do we have now? We are going to have 3 minus 2 will give us 1. 8 minus 6 will give us 2. 9 minus 7 will give us 2. 4 minus 3 will give us 1. And this is our answer. You can see that it's a very easy something, right? Okay, we are asked to subtract this from each other. We have 2, 2, 3, 2 minus 1 minus 2 minus 3 minus 1. Okay, this one is going to be a bit, but I want you to pay attention to the signs. Pay attention to the signs. So how do we solve this? This is going to be equal to 2 minus 1. Remember that this is minus 1, not just ordinary 1. So it's going to be 2 minus 1. Then this one will be 2 minus 2. 2 minus what? Minus 2. All right, this one will be 3 minus 3. 3 minus 3. Then this will be 2 minus 1. 2 minus 1. So we're now going to have, note that minus is plus. Minus times minus is plus. So this will become 2 plus 1 to give you what? 3. 2 plus 2 to give you what? 4. 3 plus 3 to give you what? 6. 2 plus 1 to give you what? 2. And this becomes your answer. The only thing here is that you should pay attention to the signs of what? Of your elements. The same thing goes to when you're asked to add together. Okay? Assuming this is addition, let's change this to addition so that you see how this goes. Assuming we are asked to add these two together, what do we do? It's going to be what? 2 plus what? Minus 1. That is 2 plus minus 1. Then this one will be 2 plus minus 2. 2 plus what? Minus 2. Now, this will be 3 plus minus 3. 3 plus minus 3. Okay? And we are going to have 2 plus minus 1. 2 plus minus 1. Now, this is equal to, note, before we did minus, right? Minus times minus is plus. But plus times minus is minus. That is why I said, let me use this addition here. Plus times minus is what? Minus. That means for here we have 2 plus minus 1. 2 plus what? Minus 1. The same thing as 2. Plus times minus will give us minus. So it's going to be 2 minus 1, which will give us 1. So let's go ahead and solve it. So we are going to have 2 minus 1 for here. You are going to have 1. This one will be 2 minus 2 because plus times minus will give you minus. So you are going to have 2 minus 2 to give us 0. Now 3 minus 3 will give us 0. 2 minus 1 will give us 1. So you notice that what do we have here? What do we have here? We have a unity matrix, right? That is a matrix with what? That has so this becomes our answer and is a unity matrix. You notice that our final answer is what? A unity matrix. Then I think we have to stop here. Thank you so much for watching. Tune in next time so that we'll continue from where we stopped. Bye.